fingers and wait for a week in order to see if the lens centers. If not, then you need to wash out. But if you are lucky in the lens centers, then you are not using the washout period. So that's very, very important. Yeah, you have a question? Or, and there's another question. Yeah.
So the second year, you order a new pair of lenses for the patient, and then if everything is okay, how often do you see the patient?
Oh, I see the patient every 6 months. And also I perform axial length measurements and cycloplasia every year. But it's up to you. Yeah. Sorry.
Do you refit if you see the axial length increase even though everything with the lens on is fine?
I don't understand.
If the axial length actually is increased,
Yeah.
but everything looks fine on the fluorescein pattern,
Oh.
obviously you refit.
Okay. This is a myopia control issue. And I will provide a lecture Saturday night. So I hope you will be there. But by the way, axial length increases, but because it's natural. Even in an emetropic child, axial length increases 0.09 millimeters per year. Normal. At around 13 years old, it's around 0.1 millimeters per year. That emetropic. Eye growth natural. But in a myopic, it increases twice or 3 times more. That's the difference. Okay? So axial length increases. The fact that the eye of your child increases the axial length in a very low amount, it could be considered normal. That's very important. We want to have 0 increase in axial length, but it's not possible. At least today, maybe in 10 years. Okay? Maybe. Axial length is one measurement. It's one thing. We will talk more Saturday about that. Yeah.
Just want to know what type of the machine that you use to measure the axial length. You use the contact type ultrasound or the ROL master?
Okay, that's a money problem. So I use
Yeah.
I use this ultrasound.
Okay.
That is maybe the worst. You have three options.
Okay.
One is Lexner, that is the best. Second one is IOL Master, the second one good. And the third system is an ultrasound that Michael Lipson showed many times in his lectures. I don't remember the name. I guess it's called Paune or PALIM or something like that. It costs around $7,000 and is using the tip using the water there. So it's not air contact, it's a water contact that is much more reliable. And Michael Lipson showed in his studies that the results with this ultrasound device is pretty similar than IOL Master. So it's a good option. But I don't remember the name. Ask Michael. Ask Michael Lipson. Okay. Go ahead. That's beautiful staining. Okay, we talk about tears, management, the preservative-free, everything like that. This is usually because we have contact in the apical zone with the lens. That's erosion, that should be not. And usually it's created at the moment that the patient takes out the lens. Yeah. So it's very important, uses 2 fingers and pop out the lens without moving translation. The lens should be released like this way. Okay. Okay, bubbles. Bubbles should be never there. Even if you have a very stiff fit. The bubble problem is when you put the lens on. If you put the lens with the tears inside and from down to up, face down, you will never have any bubble bubble inside the lens. If a bubble is over there, you have problems. First problem is the lens is uncomfortable. Second problem, you have thin revealing because the bubble could split in millions of small bubbles. And third problem is here you have a dry cornea, so you have staining because the bubble dries this area. So bubbles should be avoided, always. That's the reason again to ask the patient, please put your lens on. I will look you. Then I will look if you have bubbles or not. If the patient put the lens on with bubbles, you need to teach him, teach her to do properly without bubbles. Very important. Very important. That's the deep revealing infamous. And this is some changes. This is same patient, same eye, two different lenses with 14 microns difference. So it's one step mark. Quarter diopter flatter in each curve. And you could see that we increase the optical zone treatment diameter on cornea. Okay? If we look at the feet, we see here, it's very difficult to see it, but we have a little bit more pressure on the edge, and we have fluorescein in the center. This is a beginning. Yeah? Again, same thing. You can see here, yeah, the alignment curve in the periphery is darker than the external one. So the lens is too steep in the alignment curves. What we do, we change one step for every curve. The easy way to do that. Don't think so much. Click. Every curve is flattened, and then we have a much better, not yet, but much better alignment for everyone. And we have the treatment is better. This is same, and this is very important thing. I will talk more in the conference about myopia control. But one way to obtain a narrow optical zone diameters is to have more tear layer under the back optical zone of the lens. When you have a lens that is too steep like this, you will obtain a narrow optical zone. The inner ring, this ring is created from the back optical zone of the lens, that's the central ring. The external ring is here. This is the external ring. This is created for the reverse curve. When you have enough pressure in the center, then the central ring expands and joins the ring that comes from the reverse curve. And both together creates the perfect treatment. If you don't have enough pressure in the central ring don't expand. Or if you don't have pressure at the end of the reverse curve, the peripheral ring don't move in. So then you lose treatment effect. Okay? Understood? That's very, very simple. Here we can see the series of lenses flattening. Okay? That's the same. And now we are ready for the final exam. Okay. Fluorescein, topography, number. Which number corresponds to the fluorescein pattern? 2? Okay, sure? Let's see. Let's see. Yes, 2. Which number? 1, 2, 3, 4. Okay. Who say 1? Who say 2? Who say 3? Who say 4? No? It seems 4? Why? Oh. Why? Because we have a lot of fluorescein. It's too too much separation in the center. When we have not enough pressure in the center, we have small optical zones. And here, we have a lot, a pool of fluorescein. Yes, a lot, huge thickness of fluorescein. Which map? 1, 2, 3, 4. Okay. 3. Okay. 3. Okay. Here, again, we have we have pressure in the peripheral zone. The alignment zone is pressure. We have a small bearing area in the center because you have a lot of fluorescein there. Which one of these is? The lens is centered, by the way, so. Yeah, this case is easy. The remaining. Okay, next one. What you see here? The lens is. We start from the center, okay? What you see here? Oval. That means what? Toric. Okay. You see the first alignment curve is touching just in these points, nasal temporal, but is not creating pressure here, up and down. The second alignment curve is more or less acceptable, but is smaller. So it means the lens is flatter in the alignment curve. It's too flat in the periphery. Okay, which map it is?
2.
2? 4? Okay. 2. Because we have some contact. And we have an irregular optical zone, and we need to increase a little bit the sagittal height in the center, and we have a little movement up, not so much. Here is an oculus topographer. It's not so clear than the previous one that was keraton, but you could see here is almost, the ring is not well defined. So that's because we have not not enough pressure in the end of the reverse curve. In the upper zone is no pressure, so we have not good red ring in the upper zone. Okay. Here the lens is. We start from the center. You see, okay, the center is okay. Here. We see the diameter, the alignment zone, nasal, temporal, up and down, and the diameter. Pretty acceptable, yeah? Which number?
1.
Sorry? 1? Yes. Perfect. What we see here, we start from the center. This is bearing, touching, fluorescein. What do you see there? Sorry. You see fluorescein, yes? So we have something there that is not creating treatment, and also the lens is decentered. Which map is decentered? 4? 3. Okay. Okay. Again. What we see, the center, we don't see fluorescein here, more or less. Maybe something is there. We see alignment at the end of the reverse curve, but we don't see the alignment at the end of the second reverse curve. So we have the lower area is not aligned, it's flat. And the lens in the picture is up as well. So what we expect? 4. We have the irregular central zone and lens the center up. Okay? And the last one. What we see here. Oval central zone. Okay, oval. This is the flexion, alignment in the reverse curve, little bit flatter in the periphery. The lens is quite small. What number? 1, 2, 3, or 4? 4?
3.
3. Oh. Oh. Okay. Here we see a lot of fluorescein at the center. That is the center up. It's quite steep. You see here is more pressure in the second alignment curve than the internal, so the lens is steep in the periphery. Which map? 1, 2, 3, or 4? 2, 4, 2. The winner, the girl over there. Here, again, what we see, the lens in the center, we see a probably proper tear layer. Some tear is on the front area of the lens. At the end of the reverse curve, we have alignment. The second one is not, so it's quite flat there, and the lens moves to one side. Again, it's clear. Which number? Yes, right. This case, the lens is quite steep in the periphery. Yeah. This alignment zone is too steep. This one is green, so we have steep alignment curves. The center is quite small, but well, it's acceptable. The lens is centered. The size is acceptable. Which number?
4.
So basically, the lens is centered. Yes. So we need to choose one of these two that is centered result. Okay. Now, what we see, we have not good treatment because the end of the reverse curve is not making enough pressure. So we will think